A laser sweeps across a distant screen, and the shadow reaches the far edge. Too soon! The darkness moves, faster than light itself, crossing the surface at speeds that should be impossible. Yet no physical law breaks, and no signal travels faster than it should. How can a shadow outrun light when light is what makes a shadow possible in the first place? By the end of this video, you will understand exactly why the paradox dissolves when you stop treating absence like an object and start measuring what actually moves. The core spark is this: the shadow sweeps faster than any photon can travel point to point. But each patch of the screen only responds to ordinary light arriving at ordinary speed from an ordinary source. The mismatch lives in language, not in relativity. What is known is that the shadow boundary can cross a surface at any speed you want, including speeds far beyond 186,000 miles per second. What is unclear to most people is whether this violates causality or carries information. What else could create the same effect is any projected pattern, where the source rotates or sweeps, such as a lighthouse beam on a cloud, or the meeting point of closing scissor blades. What would confirm the explanation is checking whether anything material, any energy packet or signal, actually makes the full trip from one edge of the screen to the other. It does not. Here is one small, real payoff before we go further. You can flick your wrist and make a shadow jump across the far wall of a room faster than light could cross the same distance. And you can verify this by measuring the rotation speed of your hand and the distance to the wall. The shadow moves, but nothing travels. Picture a laser pointer mounted on a motor that spins it in a slow circle. The beam itself flies outward at the speed of light, 1 foot per nanosecond, always. Now place a screen 1 light year away and let the motor turn the pointer just once per minute. The spot of light on that distant screen will sweep across the surface at a speed determined by the circumference of the circle divided by the rotation period. At 1 light year radius, 1 full turn per minute means the spot crosses roughly 6 light years of screen surface in 60 seconds. That is 100,000 times faster than light. The old model says nothing can outrun light. The measurement says the shadow does. The contradiction is that if the shadow is a thing, it must obey relativity. But if it obeys relativity, it cannot sweep that fast. The reframe is that the shadow is not a thing. It is a sequence of independent events, each one caused directly by the source, with no connection running sideways along the screen. The reinforcement is this: you can make the shadow arbitrarily fast just by moving the screen farther away, which no physical object could ever do. Each point on the screen receives light exactly when the beam was aimed at it 1 light travel time earlier. The photons leaving the laser travel outward at exactly the speed of light, always, with no exceptions. When the pointer rotates, it sends photons in a new direction, and those photons also travel at light speed. The screen is so far away that by the time the first photons arrive, the pointer has already turned and sent a second batch toward a different part of the screen. The second batch arrives at the second location shortly after the first batch arrives at the first location. Not because anything jumped from location 1 to location 2, but because both batches were sent almost simultaneously and both traveled almost the same distance. The time delay between the two arrivals can be much shorter than the time light would need to cross from one impact point to the other. The old model predicts that if something moves from point A to point B, it must travel through the space in between. The measurement shows that the darkness appears at point B without anything crossing the gap. The contradiction is that the shadow seems to skip over the intervening space. The reframe is that there is no single shadow making a trip. There are only two separate patches of darkness, each created locally by the absence of photons, with no physical link between them. The reinforcement is that you can place a detector between the 2 points, and it will record nothing passing by. No particle, no wave, no energy pulse. Now consider the mechanism that makes the illusion so strong. Your brain stitches together separate events into a continuous motion whenever they happen in sequence along a line. This is the same process that turns a row of blinking lights into a marquee, or a series of film frames into a moving picture. The shadow does not move. The absence moves through space the way a wave moves through a stadium crowd. Each person stands and sits in place, but the pattern travels. The difference is that in the stadium, each person watches their neighbor and reacts. On the screen, each pixel has no awareness of its neighbor and no way to receive a signal from it. The pattern exists only in the external observer's map, not in any physical connection. The old model assumes that a moving edge carries information from the leading point to the trailing point. The result is that if you change the laser color at the source, every point on the screen sees the color change only after light has traveled from the source to that point, never sooner, no matter how fast the shadow sweeps. The contradiction is that the shadow moves faster than light, but the color change does not. The reframe is that the shadow boundary is a geometric pattern, while the color change is actual information, and only information obeys the speed limit. The reinforcement is that you cannot use the sweeping shadow to send a message from one side of the screen to the other any faster than light would carry it directly. Physicists draw a line between phase velocity and signal velocity. Phase velocity is the speed at which a pattern, such as a wavefront or a projected shape, appears to move. Signal velocity is the speed at which energy or information actually propagates from cause to effect. Relativity constrains only signal velocity. Phase velocity can be anything, including faster than light, slower than light, or even backwards. Water waves in deep ocean can have a phase velocity faster than the individual water molecules move. Radio waves in certain materials can have a phase velocity slower than light in vacuum. A shadow on a distant screen can have a phase velocity faster than light in vacuum. None of these violate causality, because the pattern speed does not enable faster-than-light communication. The old model treats any observed motion as the movement of a thing. The evidence treats motion as a category that includes both object displacement and pattern displacement, which follow different rules. The contradiction is that the word speed applies to both, but only one is limited by relativity. The reframe is that language smuggles in the assumption that anything with a speed is a traveler. The reinforcement is that once you separate the two categories, the paradox vanishes, and the superluminal shadow becomes as mundane as a movie projection. Here's another test. Take a pair of enormous scissors, blades 1, light-year long, and close them. The point where the blades meet can move from the hinge to the tip faster than light, even though no part of either blade moves faster than light. Each segment of each blade moves inward at some ordinary speed, but the meeting point is a geometric intersection, not a piece of metal. The meeting point has no mass, carries no momentum, and cannot be used to send a signal from the hinge to the tip any faster than a light beam traveling the same distance. The old model says the blades are rigid, so closing them at one end instantly moves the far end. The measurement says no material is rigid under relativity. Any force applied at the hinge propagates along the blade at the speed of sound in the material, far slower than light. The contradiction is that the geometric meeting point outruns the mechanical wave. The reframe is that the meeting point is not a physical location on either blade. It is a mathematical intersection that exists only in the external coordinate system. The reinforcement is that if you tried to exploit the fast meeting point to send information, you would find that the signal still obeys the light speed limit because it must travel as a mechanical wave through the blade material, not as a geometric abstraction. Return to the laser and the screen. Imagine you paint a row of detectors across the screen, each one recording the exact moment it sees the laser spot. When you replay the timestamps, you will see that the spot appears to jump from detector to detector faster than light could travel between them. But if you check the light travel time from the laser to each detector, you will find that each detector received its photons exactly one light travel time after the laser was aimed in that direction. The superluminal motion is an artifact of comparing timestamps, not a violation of local cause and effect. The old model asks, if the shadow is not a thing, why does it look like a thing moving? The evidence answers that the appearance is a result of how your visual system groups events. You see an edge because multiple points darken in sequence. You infer motion because the sequence is smooth. But inference is not the same as physical connection. The contradiction is that your perception reports a traveler, but the instruments report only a pattern. The reframe is that perception is optimized for tracking objects, not for distinguishing objects from projected absences. The reinforcement is that the same illusion occurs with a row of lights turning on in sequence. You see motion, but nothing moves except the electrical signal inside the wire, which obeys the speed limit. Now, scale the effect. The farther away the screen, the faster the shadow can sweep for the same rotation rate. At 10 light years, the shadow moves 10 times faster than at 1 light year. At 1,000,000 light years, 1,000,000 times faster. There is no upper limit. You can make the shadow move at 1,000,000,000 times the speed of light just by choosing a distant enough screen and a fast enough rotation. No energy cost increases, no relativistic mass appears, no time dilation occurs. The shadow has no mass to dilate and no internal clock to slow. It is not in a reference frame. It does not have a world line. It is a sequence of places where light is absent, stitched together by your map, not by physics. The old model says anything moving faster than light must experience infinite energy and time reversal. The result is that the shadow experiences neither. The contradiction is that the shadow breaks the speed limit, but not the consequences. The reframe is that the consequences apply only to objects, and the shadow is not an object. The reinforcement is that you can reverse the shadow's direction instantly, with zero energy, because there is no inertia to overcome. Here is what this means for your understanding. When you hear that nothing can travel faster than light, the word nothing means no particle, no energy packet, no information carrier. It does not mean no pattern, no geometric intersection, no projected absence. Shadows, spots, meeting points, and wave phases are not travelers. They are labels for arrangements of real things, and labels can change faster than the things themselves can move. The error is not in the physics. The error is in the language that treats every moving boundary as if it were a moving object. The shadow on the screen moves faster than light. That part is true. The shadow is a thing that travels. That part is false. The speed is real. The traveler is not. What this changes is the way you parse the word move. Motion is not always displacement of matter. Sometimes it is the propagation of a pattern across stationary matter, like a wave through water or a shadow across a wall. Relativity governs matter and energy. It does not govern patterns. The shadow obeys geometry, and geometry has no speed limit. So, how can a shadow move faster than light? It does not move. It appears, point by point, wherever the source aims and the screen blocks. The appearance happens faster than light can cross the screen because the source sends light to multiple points nearly simultaneously, and the screen is far enough away that the arrival times compress. Nothing makes the journey from edge to edge. Each edge receives its own photons on its own schedule, and the schedule is set by the source, not by the shadow. The shadow is the map, not the territory. The map can change as fast as you can draw it. The territory still obeys the speed of light. What you now understand is that the universe allows faster-than-light patterns because patterns do not carry cause. You can watch a shadow race across the moon, but you cannot use it to warn the far side of the moon about anything happening on the near side any sooner than light would carry the message directly. The shadow looks like a messenger, but it has no message. It looks like a traveler, but it makes no trip. It looks like a violation, but it leaves every law intact. That is the point where language and physics pull apart, and that is why the paradox survives. Not because relativity failed, but because the word move does more work than physics can support.